Okay, hi guys, it's Mrs. Millison again. Let's do the check your understanding on page 107. Okay, so a density curve, and again, we've kind of we've already been sort of thinking in terms of density curve when we kind of draw a rough curve over any kind of distribution. Okay, what makes a legitimate density curve? A legitimate density curve is that has to be above, on or above the x-axis. Okay, you can't have anything negative, so that is. And the area under the curve has to equal 1. Well, we're told there the area under the curve has to equal 1 or 100%, okay? So that is why that is a legitimate density curve. I'm not going to write all that, okay? Number 2, explain what proportion of observations lie between 7 and 8. So whatever lies between 7 and 8, we're told the area is 0.12. That's the proportion, okay? So the proportion is 0.12, or we can say approximately 12% of the observations lie between 7 and 8, okay? 3 says to trace the density curve on your paper. Well, I made a copy, of course. Okay, trace the density curve on your paper. Mark the approximate location of the median. Now, if it was perfectly symmetrical, all right, nothing's perfectly symmetrical, but if it was symmetrical, our mean and our median would fall right at the peak. It's got a little bit of a left skew, so the median is going to fall off the peak a little bit. Okay, so this will probably be the median. Again, it's still half the areas to the left and half the areas to the right. Okay, so that's number 3. 4, mark the approximate location of the mean. Now, just because it's a density curve, it still acts like any shape of any distribution. It is slightly skewed left, which means the mean is going to fall off the tail a little further than the median. Probably not that much further because it's not very skewed. So the mean's probably going to be right about there. Okay? And again, why did the mean and median have this relationship? Because it is slightly skewed left. The mean always follows the tail a little faster than the median, and they definitely both fall off the peak. Okay, great. Thanks. See you next time.